All right, so one last video on section 5.2. And I had these in the notes. I think I will skip these because we've kind of already done ones just like these. And so it's a little bit redundant. Um, so let's just skip to the last couple. And particularly this one, you want to make sure you know how to do. So we have a rational function here. And so the way we're going to do this one is we're going to turn it into not a rational function. We're going to divide the x into each of the terms in the numerator, and then find the antiderivative term by term. So that's the way to do it. There's not really a good way to do this as it is written. So we need to rewrite this, and so this will be the integral from 1 to 8. We're just going to divide the x in the denominator into each of the terms in the numerator. So 9x squared over x, that is going to be 9x. 4x over x is just 4. And then 7 over x is just 7 over x. And dx. And so now we'll just integrate each of these term by term. So 9x, the antiderivative, we're going to add 1 to the exponent. We're going to divide by the new exponent. Antiderivative of 4 is 4x, and then the antiderivative of 7 over x is 7 ln absolute value of x. And then just as a side note, in this case, the absolute value is not really necessary because we're only working with positive numbers here. So not necessary, but it's good to have it to be in for when it is. You don't have to remember. You always write it. It's always fine. Simplify this. We have 9x squared over 2, and then these are going to be the same, and then we'll evaluate this at the limits. And so we are going to plug in 8 for each, and then we're going to subtract, and then plug in 1 for each. So this would be, let's see, 9 times 64, that'd be 441 over 2. Plus 4 times 8 is 32, plus 7 times ln of 8. And then minus, plug in 1, so we have minus 9 halves, plus 4, plus 7, ln of 1. And then we can simplify that, just do all the math all at once. And we get 240 for the non-ln terms, and then ln of 1, of course, is 0. So then that will just be plus 7 ln of 8. And then that is our answer. All right, so the most important thing to remember on this one is when you have a rational, or any type, these don't have to be polynomials. Rational function technically is polynomial over polynomial. These don't have to be polynomials. We could have a square root. We could have a 4 over x here. We could have a whatever it is. But when you only have the one term on bottom, you can divide it into each term in the numerator. So that's what you're going to want to do when you see a problem like this. All right, and then the last one is a little bit more abstract, so we don't have an actual function here. So we're given that the integral from 0 to 10 of f of x is 17. The integral from 0 to 8 of f of x is 12. We want to find the integral from 8 to 10. So we're going to assume that f is continuous. And so if f is continuous, and even if it's not really, but we can assume that it is, the derivative or the integral from 0 to 10 is the same, or can be broken up however we like. And we're going to break it up from 0 to 8, and then from 8 to 10. And this is a similar idea to how we were doing these in the first section of this chapter, where we were using the geometry. And if you remember, or if you watched that video, we had one curve or line that was like this, and we wanted to find the area from 0 to 3. So we had that negative area, we had the positive area. We found this one, added it to the negative area, or subtracted it, and then got the total area. So that's the same idea here. You can break this up however you want. We could break it up 0 to 2 and then 2 to 8. We could break it up 0 to 3 and then 3 to 7 and then 7 to 10, however you want to break it up. So obviously we need to break it up in this way since that's what we're given. So the integral from 0 to 10 is 17. The integral from 0 to 8 is 12. And then we're looking for this last one. So just move the 12 over and we get the integral from 8 to 10 f of x. Dx is 5, so 17 minus 12. And that is the answer. All right, so but it uses that idea. You can break up the integral in pieces, and the pieces should add up to the whole, of course. All right, so if you have any questions, feel free to email me, and I will answer your questions as soon as I can.